Welcome to Tech at Lunch, the podcast that satisfies your hunger for all things tech while you enjoy your midday meal. So grab your sandwich, tune in, and let's dig in. Hello, Nick.
Hello, I'm Ed.
And this week we don't have Champ. To John, he's not feeling well, so he's one with a sickness, or down with a sickness, I guess, if you really want to go with some Linkin Park. Reason why we didn't do one last week. Ed was, down with a sickness. We got a whole song going on here. I luckily have only escaped with allergies. Which I guess you could call that down with a sickness too, I guess. But, here nor there. Week before last, we talked about peripherals and sustainability. So, I'm going to get your opinion on that. I know you weren't here to discuss it with us, but I'm sure you've listened to the episode and got an idea kind of what was going on. What do you think?
Well, from a sustainability, I would say it depends on what technology you're using, but some of the multi-head units we have, or some of the multi-filament units we have, where you can actually print multiple filament colors.
Yeah.
I think it's kind of neat that you're able to have a bin to kind of collect all those things. That makes it a little bit easier, to at least have everything in one place.
Yeah, what they call the poo or something.
Yeah, the poop. But I think one of the biggest things I see just from a peripheral, maybe not so much sustainability, but maybe from the point of like all the options you have now with hot ends.
Yeah.
The options you have with different type of motion control systems. What are you doing? Which flavor you choose. And then I think maybe it's not so much a peripheral, but being able to have enclosures to help control temperature. That's really a way of sustainability, because you reduce maybe the amount of energy you have to disperse to maintain that temperature in the chamber. So I see those type of things.
I can see that. And then, for me, I agree with you 110%. I've switched out my hot end before, on the Voron, and I use two different types of motion control systems here, with all of mine. I've got a Core XY and I got a regular bed slingers, and then of course the Ender 5, which is close to being a Core XY, I guess, ish. It's not a Core XY, ish. But the one thing I think we also talked about is, and this kind of leads us into this week, engineering grade filaments. So when you start hearing, say, PEEK and stuff like that, knowing, nylons, but knowing, especially we started talking about high impact, high temperature prints. The PEEKs of the world, or the PEEK CF, or stuff like that, which is insane. What do you think?
Well, I mean, that's like a game changer if you're trying to do rapid prototyping and you just want to test something and you don't have the time to send it out to a external company and have them mill it for you, or have them plastic injection mold it for you and send it back to you. With you being able to at least get those materials and have the hot end that's able to facilitate what you're trying to do, at least you can start doing some rapid prototyping to see, hey, is this concept working? Does the math match what I'm doing with the printer?
Yeah, makes sense. And, the thing is with PEEK, you pretty much have to heat the thing to Jesus. You're talking, at least, a 200-degree bed temperature and a 300-degree nozzle? And then your enclosure temperature is like 80 degrees Celsius? So you're right there about, close to ignition point. If you're printing that in your house on a standard printer, please don't. I highly recommend getting a printer that can handle that temperature. Don't try to push a Voron or anything like that to those temperatures, because guess what, it ain't going to reach it. It might, but then you probably have a chance to catch your house on fire. So, that leads us into this week. This week, we want to kind of talk about, kind of what goes into, say, rapid prototyping when it comes down to 3D printing, or if you really want to get into it, we can really dive into the world of you know, like the world of CNC. You know, if you really want to get into rapid prototyping, if you really want to go that route, which is all 100% plausible. You know, especially when you start getting into the metal I/O systems and stuff like that that are attached to the Haas CNCs. So you know, that's really start getting into some weird, I guess, advanced prototyping or rapid prototyping, I guess. The thing is, it all starts, you know, honestly, with software.
Yeah.
You know, we start talking about rapid prototyping. That's where the CAD CAM software hits the meat on the street. You know, we had an opportunity to talk to a couple people at South Tech that we really, you know, we'll have to have on this podcast soon because those guys are awesome. CAD CAM guys.
Mm-hmm.
You know, really good conversation with those guys. Love talking to them. I've been the last couple weeks working on something for my buddy using Autodesk. So I use Fusion 360, and you know, CAD CAM built into it. It's free if you're doing for personal use, which that's what I'm doing. And then it's not really that expensive for corporate use. I think it's like $530 something a year, where you can do a team, and it's like you can actually just hook everybody up online, and you can share, you know, statuses across the board. So we started talking about now. What do you think? What do you think?
Well, I look at it from the point of view of, okay, say for example, and I'll give you two examples. I'll give you one on the lower end and one on the higher end. So we'll start with the lower end. So on the lower end, for example, I have a washing machine, and the washing machine has some plastic part that breaks. And I've purchased this part, and the part broke again.
Mm-hmm.
So now, for me, I have a problem with purchasing this part again that's eventually going to break. So my idea would be, how can I make this part more robust? Why is the part breaking? So first, I can make the part as is and do testing on a few of those parts to see where the stress is coming from, and maybe redesign the mechanisms. Or I can make the mechanism robust enough to resolve the issue. So that's one of the things I see with 3D printing and rapid prototyping is problem solving.
Okay.
Now on the higher end would be like when we was talking about, you know, a system like Philips where it's additive manufacturing.
Yeah.
Maybe I have a shaft that breaks that has some component on it, and I need to have this part today. I can't wait. Or I need to have this part this week. I can't wait 3 weeks. I can't wait 12 weeks. I can't wait for supply chain issues because the machine's not running and I'm not making money.
Right.
So then that would be on the other end.
Right.
You're able to use those type of systems to get a machine back online.
Now, you talk about doing stress testing and stuff like that, you know, especially with 3D printing. Now, would you do that in your software, or would you rather do that hardware side?
Well, you would run the algorithm, but still you need to test it. Math is logical. You still have to build the item. You can't just say this equation is this without testing that equation in the physical world.
Yeah.
So yes, you do have to do the engineering first. Then you start the process of rapid prototyping.
Which, and the only reason I bring that up is because you have a lot of people out there, you know, me being one who enjoys Fusion 360, is you always start your CAD CAM and you do your testing in your CAD CAM, and then you kind of move over to, you know, the physical part, physical design. But, you know, you start dealing with stress and stuff like that, hot points and stuff like that is on the CAD CAM software. And, you know, you kind of throw it through that, you know, your flow diagrams and stuff like that, whenever you're doing stuff like that. You know, but there's so many people out there who forget that your first step should always be tested in the digital world, you know, before you take it out and put it in in a physical world, because you can spend all this time designing the darn thing. It's like if you're designing a pipe system and you realize that, ooh, I don't have the right flow. You know, I'm not going to wait until I build it and bury it to find out that everybody's toilet's going to back up. You know,
right? Yeah, well, like I said,
it kind of really ends up in a shitty situation.
Yeah,
that's literally and figuratively. Thank you for the dad jokes.
You use it, but you do. You know, it is a simulation,
right?
But the simulation is getting you with mathematical precision as close as you can get,
right?
But you do also have to put that thing in the physical environment.
The world.
So yeah, it's two camps.
Yeah.
So you can go the route of Edison and try 10,000 variations to find a filament, or you can do what Tesla said. You know, I can figure it out mathematically and do it once.
Yeah.
Why would I spend 999 tries when I can just do it on the first try?
Right.
With doing the mathematics, doing the engineering,
the simulation,
using science, looking at the physical phenomena that we know that exist.
Which, you know, now that kind of brings us into a fun little world of when you start actually developing, you know, hard products. You start really getting into some of the weird stuff, you know, like what you said, gearing and stuff like that. You can start testing, you know, plastic gears before you test metal gears. You know, before you start trying to spend the money on going out and cutting, you know, either, you know, stainless or, you know, tool steel or, you know, what is it, N3CV titanium. If you're using titanium on a washing machine, I want to see the size of the washing machine you're working on.
Yeah.
But the thing is, you start dealing in, you know, the plastic world first. Plastic's cheap. You can also recycle it if you're using the right stuff. But if you think about it, and this brings me back to the, you know, the shitty situation and this is what I don't understand. We have all these people laying pipes, building infrastructure systems. Why, for the love of God, are we not 3D printing the pipe system? First and foremost, test it in a smaller form factor. I understand you're doing your flow dynamics on it, but you know, how many times have you seen it of where they build these houses or build something, and guess what? Something's just flat out wrong. You know, I can build all of my pipe system all the way back to the main and test it by pushing water through the system in a plastic world before I dump $2 million into the ground and then realize, ooh, that really doesn't work. Maybe I should have trusted my calculation a little bit more.
Well, now we have to keep 3D printing in perspective as it is today.
Right.
So it's much more efficient, cheaper to manufacture piping on a mass scale, extruding.
Right.
The time constraints is totally different.
Right.
Could there be some applications for 3D printing used in some type of fluid system?
Well,
I would say probably.
And the thing is, if you're doing like 8th scale, you know, you can test an 8th scale.
Yeah.
8th scale is going to give you the same ramp up that everything else will.
Well, I mean, it maybe some special situations that you need that you can't get that with extruding.
Yeah.
Maybe some exotic shape that can only be replicated using additive manufacturing.
Right.
So it's still in its youth, but I can see the potential of 3D printing. Just like extruding had to get to where it is today.
Right.
One day 3D printing, not on a mass scale, but maybe I have a specialized item. You know, I need a water pump that's as strong as titanium, but it has all the characteristics as far as the thermal properties.
Yeah.
But I need it to be lightweight. So I need to reduce the amount of weight on whatever I'm doing. I don't know, maybe it's some drone or something.
Right. Makes sense.
So then it makes sense to, it makes sense to 3D print that because maybe that's some exotic shape.
Yeah.
Maybe there's some shape that we have not yet tried in injection molding. But one other thing just to add to that, as far as when we start talking, there's a reason why there's plastic in washing machines and not metal.
Yeah.
Most of it is cost reduction.
Right.
Some of it is manufacturing process. But one of the other things is that you would rather the plastic gear get destroyed than something like the the motor.
Yeah.
The motor costs way more than the gear.
Right.
So in some cases, you'd rather destroy the gear and then replace the gear because it costs a lot less to replace a plastic gear than it does to replace a single phase motor.
Right. And I kind of want to lead onto this hypothetical world here. All right, I've got a house. I'm building a house, and now I'm going to build my drain field.
Mm-hmm.
I'm going to build a drain field. I'm going to put in a septic system. I'm going to back that septic system back up to the house. I know what my degree is. And say a degree is 45 degrees.
Mm-hmm.
Whatever. Try to just be simple here. Nothing, crazy. But what I can do with additive manufacturing, or 3D printing for that matter, is I can build it at quarter scale. Something that's, I don't have to actually go out and extrude piping. I don't have to make piping. I can just print the piping.
Mm-hmm.
Something small. I can print all in one build plate most of the time. I can build my entire drain field out and have it all set up on, plates and stuff like that I need to set it up on. And I can test the flow by slowly piping water through the infeed and watching the drainage field fill up. And actually test that flow to make sure that the design is actually worthy, and actually works with what you want.
Yeah, I mean, you can. I mean, it's sort of similar like what they do with architectural designs when they use foam board.
Right, exactly.
And they build a model at some scale so a person can get an idea of what they're trying to do.
Right.
And
it's just more usable.
In that instance, then, yeah, you could use it that way. That would actually be a good way of prototyping, especially with some unique aspect to the land that you were doing, or maybe the elevation was tricky.
Yeah. If you think about it, how many times have you seen the drain field you have to add pipe to it?
Well, I mean, you could probably, scan the area or use lasers, some type of thing to kind of map out. And then you can take that back and digitally put it back into a CAD-CAM program, do some things with, hey, which one is more efficient? Mm-hmm. Hey, can I do some things different instead of taking up this amount? How can I reduce the amount of field lines I need?
Right.
Maybe field lines don't necessarily need to go, at a 45. Maybe we can come up with some other system that, like a slingshot system, where basically the water goes in one way. We make a angle at some angle that increases the velocity. The velocity runs at a certain speed. It slingshots the material further away, and you get the same properties as having a field line that's longer. So maybe it could be something like that.
Yeah. And the thing is, it's not it's not to say that how they're doing prototyping now is not right. It's just another avenue and say another tool in the tool belt. And that goes along when you start really dealing with large part manipulation. You start building large part manipulators and stuff like that, and you start dealing with like robot end effectors.
Mm-hmm.
If you think about it, I think everybody who's in the manufacturing space has wasted money a lot on buying an end effector that doesn't work. Geometry's wrong, and now I have to spend another $3,000 or $4,000 to adjust the geometry because we got engineers who can't read a tape measure adequately. But the thing is, or that think that you need to have a system to be able to commission something else. One of the two. Well, the thing is what you kind of deal with is you can actually 3D print almost all the parts. Print an effector, put it all together, wire it up, let it do its thingy, make sure it works, make sure it matches. Take the entire part off the robot, send to manufacturer and say, build this.
Yeah.
It's done. Now all you have to do is build the darn thing. I don't need to tell you how to build it. Right. That's what you do. You do you, and we do us.
But if you do that in CAD-CAM before, and it works, then you can send the CAD-CAM because you've already tried that prototype to say, hey, this works.
Right.
Then you have that prototype to compare to what comes back as a, say, like a reference part.
Yeah.
You can do the reference between the two with some type of measuring system, laser, whatever you want to use. And then you can verify, if you're off or not, and then go from there because the accuracy of a lot of the additive manufacturing, depending on the level of printer you have, can be very, very precise.
Yeah, and the thing is for me, it's how do you save money? in the manufacturing space? You know, how do you speed up the manufacturing space? And also, not only that is how do you get more people interested in the manufacturing space? Because if you have an entire division dedicated to your company that is dedicated 100% to rapid prototyping, to building or printing or setting up these end effectors, or building and setting up pieces for a line, they do all of it. You know, a bunch of CAD CAM guys, and then they got hardware, software, 3D printers, Haas CNC machines, or whatever CNC machine you want to use that day, you know, available to you. And then these guys or gals or whatever want to go out, and that's what they do. They do rapid prototyping, you know, using 3D, and we'll even bring up 3D scanning. You know, they could use these 3D scanners and CAD CAM software and build out what has to be built out and printed out.
Yep.
Could you imagine the STEM implications that comes out of just doing nothing but rapid prototyping for people? Or at least rapid prototyping at your own company, and how fast you can get people interested in wanting to work for you?
Yeah. Yeah. Like I said, that's the... I think really the point that's being missed with additive manufacturing at a prosumer, if that's the term you want to use, or I would just say advanced hobbyist. That's what we're missing.
Yeah.
It's not meant to print out, a rubber ducky, or it's not meant to print out, some Spider-Man, whatever. That's cool, and there's nothing wrong with that.
Right.
That gives us the art, part of STEM. They give us that part. But for me,
STEAM.
STEAM, I'm sorry. But for me, it's, hey, I got a problem, and I need to solve it.
Yeah.
But I don't have the tools. Well, now I do have the tools.
Right.
I can use any cloud-based application that can do CAD CAM and start there. And then if I need to go further, I can use something more advanced.
Right.
But I can at least start there to build things like maybe I want to put my hands on the 6 machines or the 7 machines, the 7 simple machines.
Right.
Or maybe I want to, how does a bearing work? Maybe I want to 3D print a scale of a bearing so I can see all the pieces of a bearing just to put it in my hand. If I am a young person that hasn't had the opportunity to work on these things, that's a perfect thing to say, hey, I want to know how a bearing works. We'll go over there and 3D print it.
Right. And, I think we've kind of hit 22 minutes in, but I think we've hit the bread and butter, of why we talk about rapid prototyping, but rapid prototyping. Rapid prototyping, advanced additive manufacturing, and subtractive manufacturing. I think we've kind of hit that bread and butter part. So you think about it, rapid prototyping on any genre, it may get 3D printing, CNC, float, water jetting, any of that type of stuff, right? You cannot do any of that without having STEM, and I'll throw STEAM in there because we got to have the art people, available to do the 3D AutoCAD and the fun drawings, because
and also don't forget places like ILM.
Right.
Star Wars wouldn't be the movie it was without the engineering done by ILM.
Right.
So we do need, and there is a need for that.
Right. And the thing is I don't think that you can do any rapid prototyping or any of that without having a complete STEM environment. You have your entire team is STEM. You have scientists who are working on certain things. You have engineers working on certain things. And the thing is they're incorporating math into all of this, and you got the art guys doing their thing. The engineers and the math guys and the technical guys are feeding data to the art guys. And the art guys go, okay, and they're building what they got to build because that's what they do best. Then the science guys are taking that and putting it through the science side of CAD CAM, letting it rip, and then sending it back to the tech guys and saying, go ahead and print it. And then the engineers are building it back on the line. You cannot have a rapid prototyping section in your company, or a company at all that's not, wrapped around STEM, or wrapped around additive manufacturing, or advanced, or advanced manufacturing, but wrapped around rapid prototyping, without having STEM. You just can't have it. It doesn't exist.
Mm-hmm.
You can try. By the love of God, please do. Because it ain't going to go far.
Yeah. I mean,
unless you want some wonky shapes, which go right ahead, be my guest. Well, see how that works out.
Like I said, it's a reason why we lean so much on mathematics. Even back, we can see the mathematics all the way back to antiquity.
Right.
And they didn't, there was some trial and error, but because of trial and error, people started to study to try to figure out what were the mechanisms behind what they were seeing.
Right.
Which was,
Makes sense.
that was the birth of mathematics.
Yeah.
And logic. And physical properties of physics.
Right.
So you a tinkerer can make things.
Right.
There's no doubt. And probably can make really, really advanced things.
Yeah.
But do we really want to have a wind-up toy as the engine to take a rocket to propel off the planet? Or do we want to use science and figure out what type of propulsion system we have to have in place to overcome gravity to get into space?
I kind of want to watch both.
Yeah. I mean, you want to watch, but which one of those you want to fly on?
I want to see how that wind-up toy would work,
I imagine it's mathematics to say that it can happen.
And, we've already got a company out in, Nevada that's going to slingshot a rocket into orbit.
But that's a little different.
Yeah, you're using a trebuchet method. You're also using gravity.
And you're using the principles of physics.
Right.
Whereas if I'm winding up...
Yeah, kind of the same thing if you think about it. Spinny to launch it.
It's physics.
Yeah.
But what I would love to see the wind-up mechanism that's able to make that amount to overcome gravity.
Oh, yeah, me too.
Yeah, and if someone can do that, I'm all for it.
Right.
I'm going green then.
Yeah.
If we can just take a key and go wind up rockets and shoot them off the planet, hey, sign me up.
I want to see the rubber band for that one. Remember the old rubber band toys you spin up and launch?
Yeah.
Those things. And the poor sap that's sitting down there and going, I think I got one more loop to go.
Yeah. I'm just saying, like, even the rockets that I had that went, 100, 200 feet, they had some kind of propellant that propelled them.
Yeah. I grew up making those rockets too, and stuff like that. You kind of chase them across the field, and but that's everybody's introduction to STEM.
Yeah.
It is how it goes. And a lot of people get lucky enough to have, family members who work in, some of these weird environments and stuff like that kind of get you going on it. But, it's just when you think about it, that's when you start getting into, everybody's been rapid prototyping for years. They don't know they're doing it. If you build something out of wood and go, oh, look, that works. Okay, now let me build it out what it has to be built out of. Or change it up because I tried to build out of scrap pieces. Guess what you did? Rapid prototyping. Guess what you used? Principle of STEM. It's one of the things where, you hear people going, I'm never going to use STEM. Yeah, you already have, and you're saying you don't. So, if you got people in your life who don't like school, say, I'll never use this. Cool. Hand them a chop saw and a 2x4 and a screw gun. Guess what they're going to
use? well, even carpentry, which is probably, goes back is
eons.
And it goes back to antiquity. Because there was somebody doing this type of work, maybe not with the tools we have today, but someone was doing this type of work. Right. Whether it was timbers or whatever they were using. Or if they were just using...
It was like the Viking age, too, if you think about it.
If they were using mass of dirt or whatever, or rocks or stone. Even those guys use math.
Yeah.
Maybe not complex math, but they were using geometry and trigonometry.
Yeah, they're also using engineering principles.
So I'm saying, like, you're using it. So maybe a better way to say that is, I can't see how I'm using this, but you're using it.
Right.
Like, I can't see gravity, but yet we know it exists. And I can do very rudimentary experiments to show you that it exists.
Yeah. And, some people out there, I think, sometimes think they can defy gravity, and we'll see how that works out. Those people who trip on hot air. But, it's the thing is I think that sometimes we deal with the fact that the principles of why and how you use it on a daily basis isn't very explained very well. Because you got some of these teachers out there, which we love our teachers, but I think they're overwhelmed by the amount of kids they got. Mm-hmm. They don't have time to sit there and explain every little thing that that what they do it for.
Right.
You can't. It's hard to tell a kid in middle school or high school, well maybe high school later, but that hey, you can use STEM or versions thereof in everything you do every day. You can do, rapid prototyping almost every single day. If you draw something on paper and then go build it in physical form, guess what? You did rapid prototyping because you made sure that, hey, look at this, I tried it. Mm-hmm. My math numbers are right. However, you start getting into where it's like, hey, guess what? This is where, all these other engineering ideas come into play when you start doing it in physical form. And I really think that, we missed the boat, when we try to explain rapid prototyping to some people, and they don't quite understand where that's going. They don't understand that, hey, it's STEM related, but it's also the fact that we got companies that are missing the boat, that aren't taking advantage of this to support their companies and support their people. Mm-hmm. You get a lot more people, a lot more interested, a lot more quickly, if you gave them something fun to work on.
Well, manufacturing has forgotten their ecosystem.
Well, they've forgotten who they were.
Well, when I say ecosystem, what I mean is even in say the ocean, there's an ecosystem.
Right.
And that ecosystem is dependent upon things inside of it. When you start to focus on profit, and this is the sole focus of your company, mm-hmm. then you lose sight of the things that allowed that company to come in existence. Mm-hmm. You have to have resources to replace resources. So just like we have seasons every year, and where we have things grow and things die, mm-hmm. the same way you have in manufacturing. People come into the industry and people leave the industry.
Right.
So if you're not supporting the ecosystem, then you do not have the resources to backfill these people that leave the industry. Mm-hmm. And what happens is you have gaps.
Yep.
So there are some things you can do, but now we can add cobots.
Yep.
We can add other advanced manufacturing techniques, AGVs.
Yep.
We can add machine learning and AI.
Yep. Inline 3D printers.
Things of this nature. But you still have to have somebody that's savvy enough, or somebody that's technically savvy to be able to maintain these things.
Yeah.
So you still have to maintain the ecosystem. So the ecosystem is the school system.
Right.
And that's where the manufacturing, that's where it should be no competition between Siemens and Allen-Bradley when it comes to the ecosystem.
Right.
They both
had to benefit from it.
Instead of trying to sell something to the school systems, you can sell it to whatever company.
Right.
You want to have an agnostic type of control system so that everybody can learn PLC programming.
Right, exactly.
So it doesn't matter if you program Siemens or if you program Allen-Bradley or Mitsubishi or whatever brand, Omron, whatever you pick.
Right.
It doesn't matter. That's the problem, is everybody's only concerned about themselves, mm-hmm. and they're killing the ecosystem.
And that's where when I start thinking, what they forgot is who they were. Why did they come into existence, and why are they? I know they came into existence to make a profit and to make money, but they forgot their main goal. And I think some of these companies are forgotten who they are, and and the thing is, it's like, cool, we're gonna make a profit, at the extent of the fact that they're losing people in the industry daily and hourly, for that matter. But the thing is that's where I think setting up rapid prototyping cells will help get some of these companies back to prominence. Mm. Some of these companies that can sit down and go, okay, yeah, we screwed up on that one. That's us. We'll take that. We'll move on. We'll come up with something else.
Yeah.
I really think that you need to take, for example, possibly led by OPCUA, because OPCUA seems to have the ear of everybody. We saw that at South Tech. We noticed they have the ear of everybody. Everybody else on their wall.
The only problem with OPCUA is OPCUA in that organization. So it's not OPCA, it's the members of OPCA.
Right, exactly.
So you still have a problem where Siemens stuff may not work with Allen Bradley stuff. But that's the issue.
But here's what I mean by that, and this is where I'm going with this. And I think that there needs to be a push to make a PLC-based system. Be it whoever, that does the hardware, because God forbid they're going to argue about that until it's blue in the face. But make it to where, it's STEM capable, where it's easy to teach, it's easy to program, maybe not too easy, we don't need that. Make it, but also make it where I can rapidly use it in rapid prototyping events, like setting up, 3D printed robots or something like that to teach robotics. But and this is where it's going to sound nutty and I'm never going to get away with it, is have the companies work together and make that piece of hardware understand multiple programming languages. Because then schools only have to buy one PLC type to teach all the different languages that are, programming.
I wouldn't even teach the different languages. I would do it this way. When I teach just the concept of programming.
Right.
It's not Python, it's not C, it's not C++. I'm teaching the concepts of programming. What do loops do?
Right.
How do we iterate over a loop?
Right.
That's what I mean. That part, just the bones of PLC programming need to just be taught that way.
Yeah.
And then whatever the school wants to pick, that's fine.
It's the specialization track, yeah.
Yeah, but I'm saying, just like we teach physics, we don't teach European physics and American physics. We teach physics.
Yeah. And the thing is, I think that's also where the open source community using OpenPLC
right.
can get into play, and you can teach the basics there. And then it's, hey, if you want to specialize in Omron or Siemens, let's take these classes.
I 100% agree with that. And I think that's the way.
And it's like, and the thing is with that, then it's like, okay, cool. If you want to specialize, then I think then you also need to do is if you want to specialize in rapid prototyping, you're going to start with CAD CAM, whoever is there, Autodesk, whoever, Fusion 360, whoever.
Or the principles.
Yeah, the principles.
All I need is the bone.
And you can use OpenSCAD for that. And then from there, it's, hey, let's go specialize in these people. But the thing is, at the end of it, they all come together for a final project where it's, hey, you're going to work with 3D printers. You guys are going to work with, some of our CNC machines. Yeah. And you work on a project together. And then pretty much you take that and integrate it with the guys who are learning PLCs and stuff like that to actively build the line.
Yeah, like I said, when we teach the 6 or 7 simple machines,
we
don't say this is a Acme simple machine and this is a Walmart simple machine. We teach simple machines. I'm saying, why are we not teaching advanced manufacturing?
Yeah.
We should teach, those groups should get together and say, hey, here's what they need to know at this level to understand when they get to our stuff.
Right.
That should be the goal. The goal is not to make Allen Bradley, Siemens all one. When I say agnostic, I mean an agnostic curriculum that is not controlled by Siemens or Allen Bradley. They work together to say this is what they need to know to understand this.
Right.
And that's the curriculum we teach. I go back to it, mathematics. When we teach mathematics, we teach it at different levels. So arithmetic is different from algebra.
Right.
Algebra is different from geometry.
Yep.
But they all tie together because those are things you have to master to get to understand it in algebra. Those are things you have to learn to understand it in geometry, trigonometry, calculus, and more advanced mathematics, linear algebra, differential equations, or whatever mathematics you're taking.
Yeah, I agree with that.
We teach the core concepts.
Yep.
I believe all of these companies, robot companies, PLC automation companies, 3D printing companies, so that's additive, subtractive. I don't have to teach you my proprietary information. I just need to teach you what you need to know to be able to use the tool.
Right, exactly.
Teach me the core concepts to be able to master the tool.
Mm-hmm. That makes sense. And the thing is will we ever see that? Maybe. Is it going to take a lot of pushing? Yes. Is it going to take the somebody from on the industry side saying, "Hey, guess what, dummies? You really need to start talking." Yeah. And the thing is that's when I kind of hope that somebody like SME gets involved and says, "Hey, guess what, guys? Y'all need to get it together, figure this out." Instead of being all for one for all, we need to come together at least and do, this in STEM, and support the growth of the industry. If, like if y'all saw the YouTube video, we talked about, what the next steps are as far as for, for SME and what they're moving, how they're moving forward. But it's, as far as with the challenge. However, if we don't get the companies to agree and the companies to talk to each other, the companies to actually be friends, then it's pretty much out the window at that point.
Right.
I hate to say it, but it's just not going to happen because somebody. Well, I learned Siemens. Well, now you have a job work with Omron.
Yep.
Oh well, I know Omron well. Now you got a job working with Allen Bradley.
Yep.
Oh well, I only specialize in this. Well, yeah, too bad. Figure it out.
Well, it kind of to me is as simple as if I learn the core concepts of driving, I can obtain a driver's license in any state in the United States.
Right.
Because I understand the core principles of driving.
Right.
So who cares what state it is?
Right. Then get together and teach the core freaking concepts.
Agree on a curriculum.
This is going to sound kind of funny, but a driver's ed for advanced manufacturing.
I mean, it makes sense. You have to maintain the ecosystem.
Yeah.
If you do not maintain the ecosystem, then you will not have people to maintain the ecosystem. If you don't have the pieces, then you can't do it. You can put all the cobots and all the robots and all the AI and all the everything you come up with. Somebody still has to be able to come up with that technology.
Yep.
We are not at a point where we're the Matrix. We're a long way from the Matrix. I know people are dreaming that it just come tomorrow, but you're a long way.
Yep.
And then you're going to get what you're going to get when you make the Matrix. So make the decision. Either man make decisions or machines rule men.
And, and the thing is that's when you start getting into the rapid prototyping stuff. Make it interesting.
Yeah.
So teach a driver's ed for advanced manufacturing. And at the same point, make a driver's ed 2 that focuses only on rapid prototyping. Because then you can tie them both together. Because if you understand this one, you understand the other one.
Yeah.
I swear. It ain't that hard.
And make it projects and not multiple choice questions or some essay questions, because those things don't mean anything.
Right.
There's not one multiple choice question that's on the manufacturing floor. Exactly. Not one. But there are projects.
Yep. So, the thing is that's kind of where that goes. Is, work at the project level, work at the, the together level. Don't fight each other over things. Bring in experts from all the different companies and have them talk to your people. And work on projects with them.
Right.
So at least your people will understand who they are.
Right.
Because without them, guess what? You can't teach nothing. But, we can yap about that until, the day is blue.
Yeah.
So, we kind of ran a little longer than usual. Well, not really. Actually, the day was pretty normal. But, we want to turn around and say, thank you, to every single person. What was it, just a couple weeks ago? We were talking about wanting to hit 2,000. 2,000 all-time listeners. We were fighting for that. Fighting for the last 5. But guess what, you guys stepped up and crushed it. We're right now at 2093. Guys, we're doing something. Hopefully, I can say hope. Hopefully we're getting the ideas out there. As long as people are listening, we're happy. As long as it's making sense, we're even happier. We love having conversations with y'all. Love having conversations with the guys in the industry. Because, every day we have those conversations. It's one more check in the box that we get for saying that we're trying to advance the STEM message and the STEM idea one step further. As what I can see is we've kind of advanced that 2,093 steps.
Yep.
We're getting there. We might get a mile eventually. I think we're a little bit over a mile now. Depending on how big your feet are and how long your strides are.
Yeah.
And if you're champ, it still might be the half mile. But here nor there, walk with them across the frickin' convention center floor. I'll tell you one thing, that's how that goes. But the thing is we want to say thank you. Go take a look at the YouTube channel. We just posted some stuff out there a little while ago. We'll be doing more and more. Promise. Go take a look at Vulcanar 3D. We'll be bringing out some more t-shirt designs. I know Champ has a few, and I have a few STEM ideas for some t-shirts we're going to be throwing out there for everybody. Printed Heritage, go take a look at some stuff we got going on there. And let us know if y'all need anything. If y'all want to get together and talk about something, we'll set up a live stream one day, and we'll have a conversation. What does everybody want to talk about in STEM? As far as STEM with advanced manufacturing, that might be something that we do, just shooting the crap and just seeing what everybody thinks. We'll do like a happy hour one night, set up the camera and just talk, and kind of see what people want and what people want to talk about. So whenever that comes out, we'll make sure we let y'all know at least a couple weeks in advance, or at least a week in advance or less. Let's see if who joins in. But again, I just want to say thank you. We appreciate it. Didn't think we'd ever be at this point, but guess what? Here we are. So I'm going to turn it over to Ed, and y'all have a good one.
I'd like to agree. I agree with Nick. We appreciate all of the support. We appreciate everyone that's giving us support of the podcast. All the people that's giving us a little love on YouTube. And I kind of echo the same thing Nick says. If there are any students or STEM teachers that are interested in maybe talking with us, we'll be interested in talking with you, maybe give you some ideas to maybe refreshing some of the curriculum you're using, or maybe you guys can give us some ideas, for topics that we could cover, to bring more focus to STEM education. Also, I would also like to, reach out to any junior colleges or technical colleges, or any of our military personnel that are, transitioning. Any of the armed forces that want to reach out to us, we'll be happy to work with you guys and maybe talk to you guys about some of the things we see in manufacturing and how you can bridge that gap from serving our country to helping to maintain the manufacturing industry in our company. So, our country, excuse me. But if you guys are interested in a live stream, or maybe if you guys are interested in anyone that's close to Charleston or around South Carolina, that's interested in meeting, we can meet somewhere and maybe have a meet and greet, or maybe you guys could give us some ideas. We'll be open to you guys give us 4 or 5 topics you want us to talk about, or give us 4 or 5 points, and we touch on those 4 or 5 points. But as always, we'll appreciate the support, and thank you guys for tuning in.
All right, y'all. Have a good one. Bye-bye.
That's all for this episode of Tech at Lunch. Thanks for tuning in and joining us for this tech-filled lunch break. We hope you enjoy the show, and don't forget to subscribe on all channels. And also, you can find us on YouTube under Vulcanar Technology Solutions. And join us for our next episode, which gets published every Wednesday at 8 a.m. All right, y'all. Have a good one. See you later.